Oh yeah, so carrying on from the last video, this key points. This wall has a heel that is what is behind the wall. This helps to resist the overturning as the soil mass holds it down. So we're taking moments about X. The unit weight of soil with gamma equals 17 kilonewtons per meter cube. Typical sand, cohesionless soil. The water table is below the base of the wall, and therefore there are no water pressures behind the wall. Oh yeah, and C dash equals 0 indicates a cohesionless soil, i.e. not clay. That's the most important thing. So first of all, what he's doing is he's taking moments about X. So the first group, let's consider the lateral forces on the wall. That is 2, which is the soil pressure, and 1, which is the surcharge load. They give lateral forces, and the height of the wall is 5.4. The surcharge is 40 kilonewtons. Oh yeah, it says in the book that the oh yeah, here we go. So I've drawn it out again. So the constant surcharge pressure, which is rectangular, that's like a pressure block, which is rectangular. The soil is obviously like hydrostatic pressure, because it's very linear variation with depth. The retained soil pressure is triangular. The distance to the centroid of the pressure of the surcharge is h/2, and the distance to the centroid for the force to the centre of the pressure of the soil is h/3. Check that. So first of all, let's check the pressure calculated for soil at the base. The P base soil, P base of the triangle, that is unit weight of soil times the height of the wall times the active soil pressure coefficient. Ka is given as 0.22. So checking the textbook, that is given as 0.22. I think it says in the book that the angle of friction, it's got gamma dash equals 40 degrees. So and take delta is 30 degrees on the base of the wall. So that's the friction. So what we're looking at is gamma dash, which is 40 degrees. So I'll do another video on how they get that, but if gamma dash equals 40 degrees, Ka is given as 0.22. So the pressure on the base is 0.22 times 5.4 times 17 gamma, which is Ka times h times gamma W equals 20.196 kilonewtons per meter squared. Therefore, the force of the soil is area of the pressure of the block triangle is half times base times height equals B times P base soil equals half times 20.196 times 5.4 equals 54.529 kilonewtons. Comment. Oh yeah, so in his work table he provides the force in one line, whereas I prefer to see and check the pressure separately. So because I was trying to understand what he was trying to do. So the pressure at the base due to the soil is 20.196 kilonewton per meter squared, and F soil equals 54.529. So let's turn over. What moment about X does the force soil give you? The result carried forward, F soil equals 54.529 kilonewtons. The moment due to the F soil is F soil times the lever arm. The lever arm is the distance from X to the centre of the force, and the centre of the force is the centre of the pressure. The distance to the centroid of the pressure. Distance to the centroid of the triangle from the base is h/3 equals 5.4/3 equals 1.8. Therefore, the overturning moment due to the soil is 54, which is the force, 0.529 times the lever arm 1.8 is 98.3 kilonewton meters per meter length. So that's all really easy. When you look at it again, it's really simple. The retaining wall example 1, continuing to checking lateral pressure forces and moments continues to refer to the pressure diagram. So we've done the triangular block. Now let's get the overturning moment due to the it's not overturning, we're doing bearing pressure, so it's just a moment. Force surcharge, very simple surcharge load which is transferred through the soil. So it's a rectangular pressure block, stress block. Force due to the surcharge is the area of the pressure block. pressure at the base height, as it is a rectangle, pressure at base is Ka times QS. It was 0.22, which is Ka, which was already given as 0.22 based on 40 degrees phi times 40, which is 8.8 kilonewtons per meter squared. The force at the force acting on the the force is not at the base. The force is acting on the back of the wall. That's equal to the pressure at the base times the height. It was 8.8 times 5.4 is 47.52 kilonewtons, and the moment is 47 times 2.7.